We began in Chapter 1 by saying that microeconomics is all about people doing the best they can given their circumstances. In Chapter 2, we then illustrated what we mean by economic circumstances for consumers. We simply took their income and the prices that they face to come up with a budget constraint. This is where we begin in panel A of this animation. With the $200 my wife gives me to go to Walmart, I can buy 20 shirts at the price of $10 each, or I can buy 10 pants at the price of $20 each, or I can do something in between. This gives me the budget constraint with a vertical intercept of 20 and the horizontal intercept of 10 with a slope of -2. From what we did in Chapter 2, we know that that slope of -2 is the opportunity cost of pants in terms of shirts. Every time I want to get one more pair of pants, I have to give up 2 shirts because shirts are twice as expensive as pants. Next, we illustrate 3 indifference curves from my indifference map that represents my tastes. We're assuming that my tastes are homothetic, which means that along any ray from the origin, the marginal rate of substitution will be the same. Along the ray that's illustrated here, for instance, my marginal rate of substitution is equal to -1/2, which means that I'm willing to give up half a shirt to get one more pair of pants. I'm not willing to give up very many shirts for one more pair of pants in this case, because I already have a lot of pants relative to shirts if my bundle lies on this ray. Of course, my marginal rate of substitution will change as I switch to a different ray from the origin. Along this steeper ray, for instance, my marginal rate of substitution is equal to -1, indicating that for any bundle that lies along this ray, I'm willing to trade 1 shirt for 1 pair of pants. I'm willing to give up more shirts for pants along this steeper ray, because along the steeper ray, I have fewer pants relative to shirts at any given bundle. Of course, as we make that ray through the origin even steeper, the marginal rate of substitution for bundles along that ray becomes even larger in absolute value. The important thing to realize about homothetic tastes is not that the marginal rate of substitution is equal everywhere, but rather that marginal rates of substitution are equal along rays from the origin, but differ across rays. Our next goal is now to determine which of the affordable bundles from panel A is in fact best for me given the tastes that we've graphed in panel B. In order to do this, we therefore have to combine our analysis of tastes with our analysis of budget constraints. And to do this, we plot both the budget constraint and the indifference curves in the same graph as we do in panel C. We could, for instance, begin with the points that lie on the magenta indifference curve and ask whether any of those bundles could in fact be best for me given my circumstances. We quickly see that they couldn't, because all of the shaded points lie above the magenta indifference curve and inside my budget constraint. They are therefore affordable to me and preferred by me to the points on the magenta indifference curve. Therefore, none of the magenta indifference curve bundles could possibly be optimal. Instead, the optimal bundle must lie somewhere to the northeast of the magenta indifference curve. Bundle B, for instance, clearly lies to the northeast of the magenta indifference curve. It contains 8 pants and 4 shirts, and is clearly preferred to all the bundles on the magenta indifference curve. But once we draw the indifference curve that passes through bundle B, we notice that there are still shaded bundles that lie above this gray indifference curve and below the blue budget constraint. In other words, there are still bundles that are preferred to bundle B and affordable to me. So we know bundle B could not possibly be a best bundle for me. Next, consider bundle A, the bundle that contains 5 pants and 10 shirts. This bundle is clearly affordable since it lies on the budget constraint. And when we draw the blue indifference curve that passes through bundle A, we notice that there are no shaded points that lie above that indifference curve. In other words, there are no bundles that are affordable to me that are also preferred by me. Bundle A is therefore the best bundle that I could possibly attain given the blue budget constraint I face. I'd love to do better. I'd love to get to the green indifference curve, but I just don't have enough resources to get there. Given the resources that I have, bundle A gets me to the indifference curve that lies as far as I can reach to the northeast in the graph without leaving the budget constraint. It is therefore the bundle that gets me to do the best that I can given the circumstances I face. The defining characteristic of this optimum that we have just found, this optimal bundle A, is that the indifference curve that passes through that bundle is tangent at that bundle to the budget constraint. Tangent meaning it has the same slope at point A as the budget constraint does. We know from panel A of the graph that the budget constraint has a slope of -2, the opportunity cost of pants in terms of shirts. We now know that at the optimum, it has to be the case that my marginal rate of substitution also has to be equal to -2, which is why point A lies on the ray from the origin on which all of my marginal rates of substitution are equal to -2, given that we've assumed that I have homothetic tastes. So at the optimum, the marginal rate of substitution is exactly equal to the slope of the budget constraint.